Good evening, all are welcome to our college, Sharad Institute of Technology, Polytechnic at our Department of Information Technology. We will start the 49th lecture on course that is data structure using C. Here vision mission of department, departmental vision statement to excel in information technology engineering education to produce professionally competent engineers with lifelong learning attitude for the accomplishment of ever-growing needs of society and industry. Departmental mission, 3 statements are there. First, to provide quality education through effective teaching learning methodologies with simulating environment for preparing technical and professional competent engineering. Second, to build up professional skills in students that will help them to succeed and progress in their personal and professional career. Third, to embed professional ethics and social responsibilities in students for society and environment. Course outcome: after the completion of course, you achieve 5th CO, that is implement programs to create and traverse tree to solve problems. Syllabus for there, total 5 units are there and their marks allocation. The syllabus for unit. Next point, continue the next point, that is the binary tree traversal. Traversal means visiting the every node of a binary tree. Traversal means what? Visiting the nodes on that tree. First of all, what is meant by binary tree? Binary tree means what? In that nodes are maximum 2 children are there, means there in a tree maximum 2 child nodes will be created, either 0, 1 or 2. Binary word is indicated. Binary means 2. That's like there are many operations that often are performed on tree, such as search a node, print some information, insert a node, delete a node, etc. Means which operations are performed that tree. For example, insert any node, delete the node, or search or print some information, means actually value will be displayed on that tree. Next point, all such operations how to done using through traversal. All such operations need traversal through a tree. Traversal operation is used to visit each node or visit each node exactly once. There are 2 methods of traversing namely recursive and non-recursive. Recursive means, in short, the recursion function already done in a C language. Recursion means again and again function will be called. In that one by one node will be visited, so again and again function will be called. So that is a recursive and non-recursive. In that no function will be called means in that use the stack data structure. In a recursive is straightforward approach where the programmer has to convert the definition into recursions. The entire load is on the language translator to carry out the execution. Non-recursive approach use the stack. This approach is more efficient as it requires less execution time. This is useful when we less execution time, but in a more execution time that will be not possible. In that time use the recursive because in again and again repeat the condition will be called, function will be called. It is possible in a recursive method. Next point, the sequence in which these entities processed defines a particular traversal method. There are the 3 traversal methods. First, in-order traversal, pre-order, and after that post-order. These traversal techniques are applicable on binary tree as well as binary search tree. The first method, it is the pre-order traversal. In a pre-order traversal, each node is processed before either of its left subtree or right subtree. This is the simplest traversal to understand. However, even through each node is processes before the subtree, it still requires that some information must be maintained while moving down tree. Means what? In that how to traversal is understanding is simple, and in that each node is processed before subtree. means one by one elements will be traversal. Still required the some information must be maintained while moving down the tree, means one by one in a level moving the node means traversal node, and one by one nodes are reached. How to reach? One techniques are there, using three techniques, means which are the pre-order techniques. In that pre-order technique, pre-order traversal is defined as follows. What is the rules or how to define that means how to done that pre-order traversal? First visit the root, after that traverse to the left subtree in pre-order, third traverse the right subtree in a pre-order. The algorithm for perform above mentioned that steps in below. That is the first step, visit the root, second traverse the left subtree, and traverse the right subtree. Let's consider the following tree where details pre-order traversing step by step mentioned. Their first step is the first we root the visit, after that left, after that right. In which techniques? In a pre-order. Okay, in a pre-order, first root, after that left, after that right. This is clear that. Okay, first print the value 45. In that pre-order traversal of the graph is the first of all display the 45. After that second step, second visit the left subtree. In that this print that 25 value. After that visit the left subtree, because left subtree are there, so 15 will be displayed. Okay, in that no any left on right subtree, so go to that in a 8th step visit the right subtree, because the third step is the right. Okay, 35 will be displayed, there is no any left and right, so go to in a right. First of all in a left subtree all are complete, after that in a right subtree. In the right subtree again print that root, first step is the root, 65 will be displayed, after that 55, after that 75. That's like non-recursive iterative pre-order traversing. In that in iterative approach of post-order traversing, in a pre-order traversing, first push the root element into stack and repeat the following steps until the root is not null. Pop the top elements and display it. Check right and left child of that popped element. If popped element has right child, then insert into the stack. If popped element has left child, then it insert into the stack. That which are the algorithms are used? These algorithms are used. First push the root, after that while root is not is equal to null, okay, means pop the root. Okay. Not is equal to null means only for root elements are there, then that will be displayed. Otherwise that root has right child, then push the right child. Otherwise root is left child, then push the left child. Example, in that examples are there. In that push the 10 onto stack, after that pop the top element. Okay. This last added display 10. Okay. In that 10 will be displayed, because first root will be displayed. After that push right child, this 20. After that of top first and then left child 5 of that top. First top is the 20, after that top is the 5. Next step, pop the top element, that is the last added, which are the 5, because the 5 is the left tree is the 5, so displayed in the display. Next and their left child of top, and no elements will be added. Okay. Next fourth step, pop the top element, that is last added, display 20 from the stack, and push the right child, that is 25. In that again 20 will be displayed, because in true 5 no any left and right child, so 50 will be displayed, 20 will be displayed. After that 15 will be added. After that from the stack and push the right child top element first, and then right and left child 11 of the top. 15 will be removed. After that which are the push, 11 will be push that. Next, again 11 will be displayed. After that 25 will be displayed. Means pop the top element which are the 11. So 11 will be displayed. And push the right child of that top element first. It is the top of that element. And then left child of top. No element will be added. Of the top element, that is last added, display 25 from the stack. Push the right child of that top element first and the left child of the top. No elements will be added. So firstly visit that root, insert a stack. After that get to 5. Okay, in that no in the left right. So that remove it by firstly 10. After that 5. Again we go to the right side. In that firstly display that 20. After that 15. That 11. No in the right side. So display the 25. It is a non-recursive. But in a board exam, ask the question. Not any mention that question is through recursive or non-recursive. Only for question is asked that search the method, means traversal methods is used, and write the answer, means what through in order, post order, pre-order. You basically use the only for recursive. Okay, not any ask the question for the non-recursive. In a question mention the word non-recursive, that time to use the non-recursive. But in generally you use the recursive method. Means what? This method. This method is used. Okay. In case ask the question, that time to use this. But 99% is not any ask the question using recursive or non-recursive. Only for question is asked, write the traversal method using that in order, post order, pre-order. So that time to use only for through recursive. Okay, next, in order traversal. In order traversal is also called as symmetric traversal. In this traversal, the left subtree is visited first. Okay, and in order, then root, and then the right subtree in order. This can be defined as follows: traverse the left subtree of that root node in order, visit the root node. After that, traverse the right subtree of the root node in order. Algorithm for perform above mentioned steps is given below. Traverse the left subtree, call the in order function. After that, visit the root. After that, traverse the right subtree, call the in order right subtree. This call means that function will be called. Let consider the example in that steps. First step is the, what is our aim? First left, root and right. So in that, what is the left? Visit to left. In under again visit the left. So third step, display the in that again check the left. 15 left is not any element, means null. So display the middle, means second step, root. After that, right, display the 15. So 15 will be display. Right, no null. So go to the in that root 25. So 25 display. Again next step 35 display. 8th step, 9th step, 9th step is left sub null. So print 30. After that, right subtree null. Again 11th step is that print the on that left subtree root is the 45. That will be display. Again go in a right side. That also again visit the right subtree. Again visit to left in that null. So 50 will be display. Again right is the null. So go to in a 65 display. After that 75 will be display. Means in that first of all display 15, 35, sorry 15, 25, 35, again 45, 55, 65, 75. Means left, root, right. Again root, again left, root, right. That's like non-recursive iteration in order traversing. In that, in iterative approach of in order traversing, repeat the following steps until the root is not null. Move towards the left subtree and the push all the left child into stack. Check the status of that stack. If not empty, then pop top of the element stack and display it. Push the right child, pop the element into the stack. The following algorithms, the steps are iterative in order traversing. That check while root not is equal to null, means go to the left path and insert all the elements on that stack. In that not is equal to null means obviously in that elements are there, so go to in the left path in left subtree. Check the stack is empty. If yes, then exit. Pop the elements from the stack and print it and add the nodes at the right on that stack. How to solve that? In that figure shows that first step, root is not null, so 10 is the root. Push the 10 and left child onto the stack. This first 10, after that 5 will be display. This is because it is left. Stack is not empty. Pop the top element, that is the last added display. 5 will be displayed from the stack, and set the right child as the root. Root is the null. Root is null, stack is not empty, then pop the top element, that is the display the 10. Okay, root will be displayed because your formula is left, root and right. Root is not null, that is the 20 is root. So push that 20 and it's all left child, that is the 15 and 11. So one by one will be displayed. The stack is not empty, then pop the top of the element that is last added, this 11 from the stack, and set the right child as the root. Root is null because in that root is null. Next step, root is null, then stack is not empty, then pop that elements added display the 15. Root is null, not empty, then pop the element, that is last element will be displayed, that is 20 will be displayed. After that, next 25 is the right tree, that will be pushed. After that, pop it. Stack is not empty, pop the top element, that is last element 25 from the stack, and set the right child as the root. Root is null. The root is null means stack is empty, then return. Next, third type, post order traversal. In this traversal, root is visited at the end, left subtree and then right subtree, then traverse in a post order. What is how to define that? Traverse the left subtree, that is left child, that is subtree of root node in a post order. Traverse the right child, that is subtree of the root in a post order, and visit the root. Means in short, left, right, after that root. Algorithm same, traverse the left subtree, traverse the right subtree, and visit the root. In that diagrammatically show that first step, display the left, visit to the left subtree, print in that left subtree null, right subtree also null, so display the root 15. Fifth step. Sixth step, visit to right subtree, in that left subtree null, right subtree null. Ninth step is that 35 will be displayed. Again go to that 10th step, display that root because left, right, after that root. 11, visit to right subtree, visit to left subtree, both are null, after that 55 will be displayed. Again go to the right subtree, null, after that 75 will display, after that 65, after that 45. In that 50, 35, 25, 55, 75, 65, after that most root, that is main root 45 display. Clear that? Non-recursive iteration post order traversing. In addition to checking the left and right child here, we have to check the left and right child is visited earlier or not. For that need to create the nested structure. In addition to data left and right child, we need to exact two fields are there, is visited to left, left means visited left and visited right, to specify that the particular nodes in a visited or not. Initially value we say v left and v right is the 0. Traversing start from the root and first left path will be traversal and all nodes in a root will be pushed into the stack, and at the end we reach the up to that leftmost node. As leftmost node is a leaf node, okay, means left node means last node, deep node means or the no any nodes are there, right or left, that is said as the leaf node. It means the that also print its data and pop the nodes to the start traversing again. A route left traversing is already done. Explore the right path and push all the nodes along with the path in the stack. Hence, reach at the rightmost node of the root node, print the data and pop node to the start traversing again. This process will be continued up to the stack is not empty. The following algorithms are there. In that, while stack is not empty, repeat the step 2 to 5. Then check firstly root of that left is not null, then top of the stack not visited. Marks that top as a visited, push root and into the stack and set the root left to the root. Go to the step again first. In the right side, in the root's right side, check that it is not null. Then top of the stack not visited, mark that top as a visited, push. After that, into set that right to the root and go to the first step. Display the again root data and set the top and status will be displayed as 0 and pop the element and set as a root. That examples are given in that set as the firstly root is the 20, that left on that left is the not null, okay, because 5 elements are there, so is not visited, mark that as a visited, push on that left sub is the 5, root 5 and root left is equal to means that 5 left and right both are the null, so print the 5 display. After that root 10, okay, their right side is the not null means elements are there, means visited, not visited, okay, mark that visited, means in that not null means visited that numbers. Push into the stack and set the right as the root. Root is the 20, left is not equal to, okay, not is equal to null means in that elements are there, so mark that one by one. That 15, 20 will be pushed on that. When on that 15, 11 that no any left and right, that time display it means pop it, that 5, after that 11, after that 15, 5, after that again 11, 15, after that 25, 20 and 10, in that 15, 25, 20 and 10. In that also root the 15, that left side is visited is equal to null, mean display that 15. Next in that 20 is root, again 25 will be next in a subtrade root, that null not null, is equal to null, mean display 25, again 20 will be display and again right main root is display, that is 10. Here two questions are there. In this through question is arise in your board exam. Perform in order, post order, pre-order traversal of the binary tree shown in below. Because this is the in order. What is the syntax? Left, root, right. So in that first left is the D, C, E. Okay, left, root, right. After that, what is your root? B. So B. After that, G. That F in the right, nowhere. So root to A. After that, I, H and J. This is the in order. Pre-order, firstly root, left and right. Display root, that is A, B in that left, that root, C, that D display. After E, go to right, F, that G, again go to that right, that H, after that I and J. Firstly root, after that left and right in a pre-order. Firstly root display means A will be display. After that B, left. Okay, in that left is also possible, so no, go to the right, go to in left. Okay, that C is the root, so C will be display. Again D is the no any left hand child, so D will be display. Again go to the right, E display. After that in that go to the B right. Okay, because your next condition is right. In that right again check that G is the left, this display. After that first F display because it's root, G display, right is no there, so go to the next. That root is the G display, sorry, H display, I and J is a pre-order. In a post order, same, sorry, in a post order, left right root D E C. After that G, right is no, so F B, then go to that I J H and E, this line. In same pre-order, pre-order means root left right, root, okay. Root will be display left, okay. Again that root 5, again 9, that root is the 7, display 1. After that 11 is, sorry, tell you the root, display 2. After that 4, after that 11, after that 3. In order left root right, so in that left 9, 5, get 1, 7, after that 2, 12, after that 8, okay, after that 4, 3 and 11. In a post left right root, so left is the 9, in a right side is left is the 1, okay. And go to the right side, again 2 are there, so 2. After that no right, so 12 display. After that 7 display, after 5 display. After that in go to that in left 3, right side no, so 11 display. After that 4, after that 8. This is the post order. Here's summary on that today's lecture. In this lecture we studied which are the traversal method, how to solve that problems, pre-order, through pre-order, in order and post order. For more for you, continue the assignment number 5, this and this. Here stop on today's lecture. In this lecture any doubts arise, then contact with me. Thank you.